Previously, we talked about solving linear equations. In this section, we will talk about solving other types of equations. Let's start with an expression containing a rational exponent. A rational exponent is an expression whose exponent is a fraction. The word rational refers to a fraction. Example, x to the 3/4, or x minus 3 raised to the 1/3 power. To solve a rational equation, to solve an equation containing a rational exponent, we need to first isolate an expression containing the rational exponent. 2, we have to raise both sides to the reciprocal of the exponent, and then we solve for the variable. Let's start with the first one. We have x minus 5 raised to the 2/3 equals to 16, and let's follow our steps. Step 1, isolate the expression containing the rational exponent. So on the left side, all we have is this expression with the rational exponent, which means we don't have to do any kind of isolation. So I'm just going to recopy this problem as x minus 5 to the 2/3 equals to 16. Step 2, raise both sides to the reciprocal of the rational exponent. So to undo the 2/3, here's what we're going to do. We are going to raise both the left side and therefore the right side to the reciprocal of this exponent, which means we will raise it to the power of 3/2. Okay, now once we do that, let's see what happens on the left side. When we multiply a power to, when we have a power raised to another power, we multiply those together. And 2/3 times 3/2, they multiply to 1. So all we have on the left side is x minus 5. So the 2/3 and 3/2, they undo each other, which is why we have to raise the left side to the power of the reciprocal. On the right side, we have 16 raised to the 3/2 power. Now, a quick recap. If you have x raised to the power of a over b, this means we have the b root of x, and that whole thing is raised to the a power. In other words, the denominator becomes your root, and the numerator becomes your exponent. So in this case, we have 16. The denominator is 2, so we're going to have the second root, which we don't have to write actually. Second root implies square root, so we have the square root of 16, and that is raised to the 3rd power. Now, square root of 16 is 4, and 4 raised to the 3rd power is 4 times 4 times 4, which is 64. So we have x minus 5 equals to 64. And if we add 5 to both sides, our answer becomes x equals to 69. And in set notation, we can write it like this. Let's take a look at the next example. In the next example, we do have to get the x minus 1 to the 3/5 by itself. We need to isolate that. So our first step will be to add 1 to each side. And this will give us x minus 1 raised to the power of 3/5, and that equals to 9. Now to undo this rational exponent, we need to raise both sides to the power of that exponent's reciprocal. So we're going to raise both sides to the 5/3 power. Okay, so this multiplies to 1, which means on the left side, we are left with x minus 5. And that's what we want. We want the x minus 5 to be by itself. Now, on the right side, we have 9 raised to the power of 5/3. So I'm going to work this out on the side here. The denominator is 3. So if I take the cube root of 9 and raise it to the 5th power, well, the cube root of 9, 9 is not a perfect cube. So in other words, no number multiplied by itself 3 times will give you a 9. So anytime you have a number that's not a perfect cube and you take the cube root of it, you are going to get a decimal. So since this can't be simplified manually by hand, we have to use a calculator. So in your calculator, and every calculator will be different, I'll talk more about this in class, but you're going to take 9 and raise it to the exponent. So on some calculators, you have this key. On some calculators, you just have an exponent key. Whatever it is, you're going to do that and put 9 raised to the power of 5/3. And this will give you a decimal answer. Now, you have to make sure that you put the 5/3 in a parentheses, because if not, then your answer is going to be a little bit off. Okay, so let's take 9, raise it to the power of 5/3, and your answer here should be 38.94. If we add 5 to both sides, do +5 and +5, then our solution for x is going to be 43.94. Let's talk about absolute value. So absolute value of a is the distance from 0 to a. Once again, the absolute value of a is the distance from 0 to a. So if we want to find the absolute value of 6, we're looking for the distance from 0 to 6. If I were to draw this on a number line, if this is 0 and this is 6, the distance between 0 to 6 is going to be 6 units. Therefore, the absolute value of 6 equals to 6. It represents the distance from 0 to 6. Now let's take the absolute value of -6, which is going to be the distance from 0 to -6. So this is 0, this is -6. Even though we're going in the negative direction, we're still taking a positive number of steps. We're still going a positive number of units because distance can never be negative. So the distance from 0 to -6 is still going to be 6 because distance can never be negative. So the absolute value of -6 also equals to 6. And because the absolute value represents the distance from 0 to a number, the absolute value is always going to be positive. Now let's work backwards. What if we wanted to solve the equation absolute value of x equals to 6? So we want to find out which values of x makes this equation true. In other words, which numbers are 6 units away from 0? Okay, so we have 0. When we say the absolute value of x, we want to find which numbers have a distance of 6 from 0. So those are 6 and -6. Both of these are 6 units away from 0. And we saw that the absolute value of 6 and absolute value of -6, they both equal to 6. So in this case, x has two solutions, -6 and +6. So in general, if you use any positive real number, and if you use any algebraic expression, I'm sorry, this should actually be if a, please correct that. If a is any algebraic expression, then the absolute value of a equals to u is equivalent to a equals to u or a equals to -u, because we have a negative and a positive solution. So here are the steps to isolating absolute value. I'll let you read these and we will do the example. So the example says, step 1, we need to isolate the expression containing the absolute value. So we need to add 7 to both sides. Okay, we're going to get 2x minus 3 equals to 8 plus 7, which is 15. Now remember, 2x minus 3, that's an expression. And the value of the expression changes as x changes. So we want to figure out, what does x have to be in order for the number inside this absolute value to have a distance of 15 from 0? Okay, so in other words, here's what we have. We have 0, and we want the distance from 0 to be 15. So we're going to end up at positive 15, and we're going to end up at negative 15. Now this distance here, we want that to be 15, but it's represented by 2x minus 3. This distance is represented by the expression 2x minus 3. So therefore, we're going to set 2x minus 3 equal to negative 15, or 2x minus 3 equals to positive 15. Because we want to find the value of x that makes the number inside this absolute value negative 15, since its absolute value is 15. Same thing over here. We want to find which value of x makes the absolute value equal to positive 15. So if we solve this, we are going to add 3 to both sides. We got 2x equals to negative 12. And then we divide both sides by 2. So we get x equal to negative 6. If we add 3 to both sides, we have 2x equals to 18. And if we divide both sides by 2, we get x equal to 9. Let's check our answer real quick. So if we did it correctly, when we plug in -6 and +9 into the original equation, it should make a true statement. So actually, you know what? We normally plug it into the original equation, but for the sake of this problem, let's plug it into the second step where the absolute value is isolated. So -6, we have absolute value of 2 times -6 minus 3, and we want that to be 15. We want to check, is that a true statement? So 2 times -6 is -12. We want to check, does that equal to 15? -12 minus 3, so we get the absolute value of -15, and now that does equal to 15. The absolute value of -15 is 15, so that checks out. So here's what we're doing. We're saying that when x equal to -6, this expression has a value of -15, whose absolute value is 15. Therefore, -6 is a solution. Same thing for 9. We have the absolute value of 2 times x, which now is 9, minus 3. We want to check, does that equal to 15? So 2 times 9 is 18, and 18 minus 3, we do know that's 15. And the absolute value of 15 is 15. So because 15 equals 15, that is also a valid solution. So our solution set is going to be -6 and +9. So the steps are, first isolate the absolute value. Once you have done that, take the expression inside the absolute value and set it equal to -15 and set it equal to +15 and solve for x. Let's take a look at another example. If we want to isolate the absolute value, we're going to divide everything by 4 because the absolute value is being multiplied by 4. So we get the absolute value of 3x minus 6 equals to 5. Here's what we do with this. This expression, so this is your absolute value, this expression inside the absolute value equals to 5, which means the distance from 0 is equal to 5. So 3x minus 6 can equal to -5, or 3x minus 6 equal to +5. So take the expression inside the absolute value, set it equal to negative and +5. So in the first case, we add 6 to both sides, and we get 3x equals to 1. On the other side, we add 6 to both sides, we get 3x equal to 11. Then we divide both sides by 3, so x equal to 1/3, or here if we divide by 3, x equals to 11/3. So our solution set is going to be 1/3 and 11/3. The next examples, I will let you think about them. You can try them out if you want to, but we will go over them in class.